Hello, Bear Sisters and Maya. I wanted to record this video just to give you a quick idea of the lab that we started on Friday, and you guys will continue on Monday. It's a lab called a chromatography lab. Chromatography just means like the splitting of colors or this kind of study of colors, that kind of thing. We've got some chromatography paper here, and you need a pencil. And what you're going to do is on the bottom of this paper, you are going to make nice little line across the bottom. It's a good idea for you guys to check out the Google slides that kind of introduce this about covalent bonding and the idea that some molecules end up sharing electrons rather than just gaining and losing them like in ionic bonding. So we're studying a few different covalent molecules: water, ethanol, and acetone, which you probably know as nail polish remover. Those are all covalent molecules that are sharing electrons rather than gaining or losing them. And that's going to give them some different properties that we'll be talking about next week. So you put your line of the pencil on the bottom of your chromatography paper. Then you need to, we've got a number of different markers, washable markers being one, or all kinds of permanent markers, dry erase, wet erase, others there as well. So I'm going to put a dot of dry erase right here. So dry erase dot on there, and washable dot on there. So now we've got two different dots. And it's a really good idea to label which one is which. I'm not going to take the time to do that, but as you can see on there, I would label that that's dry erase and that's washable, and then also to label your solvent. Solvent is the liquid that you're dissolving something in. Once again, that's on the Google slides. So we've got water as our solvent, and we've got a stir rod here. What you are essentially going to do, I'm going to tilt the computer down here. You've got the beaker, and you are going to suspend your paper in the beaker so that you can let the water be drawn up the paper, and based on the properties of the inks versus the properties of the solvent, you should see some different things happen with that ink. So let's see if I can get this. Sorry, multitasking is not always my forte. So let's move it. That's fine right there. Okay, so that's going to probably be a little bit too deep. One thing you want to avoid is dunking the ink itself into the water. And how does that look right there? And that's too far. So, as you can see, there's a little bit of a art to it, and I'm just totally botching it right now. Okay, and while I'm killing time, Maya, I hope you're having a great hockey tournament. And Bearishes, I hope New York is everything you hoped and dreamed it would be. And okay, there we go. This is far from perfect. I probably did not use long enough of a piece of paper, or my beaker's too tall, one of the two. And gosh, I'm just gonna add a titch more water. Okay, so this is really probably more water than I should be using, but that's how much I'm using to try and illustrate my point to you guys. Okay, so now what should be happening here, something called capillary action. The chromatography paper is a special paper that basically has very small pores in it. It allows water and pigments to travel through it, and you can see that water rising up that level. And on the left is, I don't know if that's your left, on this side we've got the washable marker, and on this side we've got the dry erase marker. You'll notice that the washable marker is traveling up the paper. The dry erase marker is just staying there. And once again, referencing the Google slides, there's something you can actually measure about this called the R factor. It stands for retention factor, the R value. It's basically a rating of how much your solvent, the liquid, drags that solute, or the solid thing, the pigment, the ink, up your paper. So Take a look at the diagram on the Google Slides, but that's one thing I want you to measure about this experiment is how much the various components of your ink get moved. So right now, the dry erase marker over here hasn't moved at all. It's got an R value of 0, and it tells you that dry erase is really not soluble. It's really not able to be dissolved in water, whereas over here, you can see that maybe that blue ink on the top is traveling with the top of the water line. I don't know how much of that water line you can see. Maybe if I put a piece of paper behind it, you can see it a little bit easier. Maybe not. The blue is traveling with the top of it, so it's got a high R value, probably of 1, whereas down there towards the bottom, maybe purple or yellowish colors are not traveling very much with the water, so they have a lower R value. And this is kind of the short version of this, but what you are going to do then is test different pigments, so different colors, different types of pigments, whether it's washable or permanent or dry erase or wet erase, and then test that in different solvents like ethanol and in acetone. And ultimately next we'll kind of repeat this or continue this on Monday. I've got groups for all of you guys, and then on Tuesday you're going to have to identify an unknown, just like with the flame test lab. You had to use your data to identify the identity of an unknown substance. You're going to have to identify the identity of an unknown marker based on its chromatography, or based on how it reacts with different liquids. And which that ultimately goes back to the covalent bonds, what kind of covalent bonding we have, which we'll talk a little bit more about that next week. I hope this was a somewhat helpful video. I hope you're all having a great weekend, and I will see you all Monday.